All right, so let's look at the first problem today. I just want to take out these 6 problems. All of them have to do with displacement and distance and so on. Okay, so a postal employee, so let me just zoom in. A postal employee drives or moves a delivery truck along the route shown in the figure. Okay, determine the magnitude and direction. Obviously, I will never tell you that. I will just say determine the displacement. Okay, because technically, if I tell you magnitude and direction, I'm kind of telling you what that displacement is a what. If something has magnitude and direction, it's classified as a what? No, both is a what? Is a vector. I can tell you, I can hint to you that it's a vector. You need to know it's a vector. So if I just say displacement, you should know, you should give me how many things? 2 things, magnitude and direction, okay? By drawing the diagram, by drawing a scale diagram. So they actually want you to do it with what? With the scale diagram method, or actually by literally getting some graph paper, sketching it perfectly with the correct length and the correct angles, and then doing all the what? All the geometry work. We're not gonna do that. If you have 3 vectors, why do I have 3 vectors? Because I have how many trips? How many trips do I have? 3 trips. We have a northbound trip, we have an eastbound trip, and we have a northeast trip. If you have more than 2 vectors, which method is better? Always the cosine law method or the vector decomposition method? Vector decomposition, like the one I posted the video yesterday. So let's do the what? The vector decomposition method. Okay, so on the next slide, on the slide on the right side of that slide that you have, okay, but I'm gonna do obviously my solution right here. So what I'm gonna do is what? Let me get some red lines to help me sketch. All right. So what's the most important thing about placing the vectors in the vector decomposition? Do you place them after each other or all coming out of the exact same point when you do vector decomposition? When I did it in the video yesterday, Muhammad, exactly, coming out of the exact same point. So the first thing we're going to do, everyone, is maybe on the side right here. So basically, it's just sketching a y-axis and a what? And an x-axis. Okay, so this is south, this is west, this is north, and this is east. Sure, yeah, no problem. Rulers, if you need them. Hmm, sure. If you need one. Simon, tell us. Oops, excuse me, yeah. You're good. I'll give you the green one. Okay, so where is my first vector? Come on, where is my first vector? Coming from the origin and pointing which way? North. So all you have to do is basically just do this. Oops, sorry. Oops. Okay. So all I have to do is point. Yeah, let's use black, no problem. So this is the first one. How long is this one? How long is this strip? Hmm. 2.6. So on top of the arrow, just write 2.6. Okay. Sorry, 2.6. Okay. Next, where's the next strip? So again, 4 kilometers east. Remember, because this method is amazing and doesn't care really for the scale, all you have to do is just what? Look, sketch something that goes to the east. It doesn't even matter if you make it smaller. It just has to be going the right direction. So I guess I don't have enough scale to sketch it really as 4, which should be much longer than 2.6. But again, who cares? All right, 4. Okay. Now, where is the other or the third vector going? What angle? Are we given an angle? Yes, we are. How much? 45 degrees, obviously east, north. Or in this very special case, also northeast. 45 is the only degree, is the only angle that's here and here exactly at the same time. Okay, so that means I'm just going to sketch. Oh, how long is it? 3.1. So it's a length between 2.6 and 4 and 4. It doesn't really matter. Just sketch something somewhere exactly in the middle. Okay, so I'm going to sketch it this way. And sorry, how much? How long? 3.3.1. Okay, how many total vectors do we have? How many original vectors do we have? 3. How many of them are good vectors? We have 2 good vectors, the eastbound one and the northbound one. How many do we have as bad vectors? 1. So how many do we need to decompose? Just what? Just 1. Okay. So can someone tell me again, how do I show decomposition? How do you show a vector breakdown or decomposition? Using what kind of lines, Noura? use the dotted or dashed lines, and basically you project. Get used to this word, project, or drop it, or make a shadow on here. Now, do you remember what kind of arrowhead did I use for the breakdown one? What kind of arrowhead did I use for the breakdown one? Yes. Thank you. They're not filled. Everyone, this is again my habit, just to distinguish. Look, when I do a breakdown, I'm gonna do it like this. Okay. Okay, and then obviously this one and here. Make sense so far? Okay. By the way, just so you know, everyone, a good sketching tip. Okay, a good sketching tip. Everyone, look. Whenever you sketch, listen up. Everyone, eyes on the screen. Whenever you sketch, again, because scale doesn't work. Okay, sorry, doesn't work. Doesn't matter. Um, when you sketch, everyone, what would happen? Look, everyone, if I made this 3.1 longer up to here, what would happen to the breakdown? Where would it exactly go? It would go up to here, right? Up to here, correct? Never do that, because then what? They might overlap and you might not see one of them. Do you see what I mean? So it doesn't matter if it's longer or shorter. Just make it basically so the shadows do not what? Do not cover each other. Is it making sense? Otherwise, you might undercount, because two of them are what? Are almost at the same location. Okay? That's why. Perfect. All right. So let me just erase that extra tip. There we go. So it's 3.1. All right. So let's look at these. Which direction of the east or west should I take as positive? Any takers? Which direction of the east or west should I take as positive? How many people say east? How many people? Okay. Why should we not take west? Yeah, go ahead, Josh. There's nothing on the west. So that means what? Everything is going to add up on the east. So go ahead. I'm going to use a different, oops, sorry, my bad. I'm going to use a different color for the direction. Right. Yes. So draw. I'm going to use green. So plus is east. Okay, again, how about the north or south? North. There's absolutely nothing going south. So that means just like this. Which, by the way, just like everyone, in case you're interested, look, technically, since there's nothing at all heading south, look, you did not need to use all this space for the what? For the south. You could have, again, please leave your diagram as is. I'm just telling you. For the future, you do not actually need to what? To show any quadrant that is completely not used. In this case, not just a quadrant, two quadrants, or an entire half of a universe. Okay. Oh, I need to put 45. 45. Okay. What do you want to start with? The y or the x? Like the horizontal or vertical axis? Doesn't matter? No, it doesn't, because you have to do both anyway. Okay, let's start, I guess, force of habit. Everyone, let's start with the what? With the x-axis. How many vectors do you see on the x-axis? How many vectors, including the breakdown one, how many total vectors do you see perfectly lined up on the x-axis? Two. It's the original one from here, 4, and this guy. Okay? So, oh, okay, let's so by the way, you can call them like D1 if you wanted. I guess this was trip 1, this was D1, and this was D2, like I did in my solutions yesterday. And this would be what? D what? D3. Okay, this would be D3 on the what? Is this D3 on the Y or D3 on the X? X, which means this is what? This is D3 on the Y. Okay, let's do the overall what? Let's do the overall X. Let's do the overall X. So delta dx, or sorry, you know what? Why delta? Who cares? Just dx. By the way, notation in intermediate steps, not really my concern. Let's just write dx. All right. How many vectors do I have on the x? 2. So apparently, I will write d2, the full d2, plus what? d3 on the x. Okay. How long is d2? 4? Absolutely no breakdown. It's a good vector. Plus, how long is d3 originally? 3.1. Okay. You just have to answer one question now. Is it a sine or a cosine? And you have to tell me why. Is it a sine or a cosine? Who would like to provide an answer? Yeah, go ahead. Okay, so that's the numerical trick. Since the degree is what? 45. What were you going to say? Exactly. So only for 45, it doesn't matter, right? Cosine and sine of 45 is the only angle that has the exact same cosine for both. What if it weren't 45? What if it was 10 degrees? Obviously, it wouldn't be. So you have to make a decision. So who can tell me if this length right here, is a sine of 45 or a cosine of 45? And you have to tell me why. Raise your hand if you know. Noura, go ahead. Eh, Okay, hold on a second. I am actually doing this part. Is this opposite to the 45 or right adjacent to it? Adjacent. And what's adjacent in SOHCAHTOA? Adjacent. Adjacent is? No. By the way, just so you know, we do not use tan. Everyone, in the breakdown process, we do not use what? We use tan at the very end when we do the what? Pythagorean and the angle. Is it making sense? We only use what? Either sine or what's it going to be in this case? Cosine, because look, the one I highlighted is right next to, or in math terms, adjacent to the 45. Perfect. So you just go here and you write what? Cosine of 45. All right, let's do this in one shot with the calculator right here. All right, so I'm gonna do. I have to do 45 degrees first. Cosine it. Please make sure you're on degrees. Please. Times 3.1 plus 4. So the overall distance or displacement, I should say, or movement on the x-axis is 6. I'll say 6.19. Okay, so 6.19. Are we doing miles or kilometers? What's going on? Kilometers. All right. Perfect. That's it for the what? For the d on the x. Let's do the d on the y. So d on the y. Same thing, but instead of d2, I have the full what? And instead of technically cosine, I use what? I use, instead of cosine, I use the other twin, which is what? What's the twin of cosine? Sine. That's the thing. If you use cosine for one, you have got to use sine for the other. Why? Everyone, look on the screen. It's basically because this guy now, look, everyone, this guy is what? Opposite to the 45, which is as long as this guy. That's how you always do it. Okay, so dy equals d1 plus, because both of them are pointing together in the positive direction, d3y equals, d1 is what? D1 is 2.6 plus, what's d3y? It would be 3.1 sine of 45. So that is equal to uh, sorry, 45 degrees, sine it, times the 3.1 plus 2.6. So I'm going to go with 4.79. 4.79 kilometers. Am I now done with the original diagram? What do you think? Am I now done with looking at the original diagram? Yes, I am completely done. By the way, you do not need the original diagram in any way now. Okay? Oh, by the way, did we get positive or negative answers? So, just like I did yesterday in my video, whatever is positive, I tell myself where it points. This is the dx. Which one is the positive on the x? West or east? So I want you to say points east, because that's going to help you in your last diagram. Points east. How about this one on the y? Which one is positive on the y? North. So this one points north. And now all I have to do, everyone, all I have to do is to sketch something that is 6.19 long pointing east, and from the same origin point, something that's 4.79 kilometers pointing which way? Pointing north. Okay, so I'll do it here. By the way, it doesn't matter which one you sketch first. You're gonna make a rectangle no matter what. So I'm gonna sketch something longer this way and something slightly shorter this way. So maybe this would be a good diagram. Who cares? This much, everyone? This much is pointing what? North. So I'm gonna write 4.79. And this much is pointing east. Yeah, that's good enough. How much? 6.19. Yep. Oh, we're doing this worksheet. The first problem. Sorry, this one. The university problem. Okay, what do I finish off here? What do I have to finish? What full shape? What full shape? Rectangle. So rectangle, and within it, you're gonna make a what? A right angle triangle. That's always how this method is gonna go. I don't really care if you make those two lines dashed or dotted. This is just a math problem here. And then you gun it all the way to the corner. Done. That's it. Please always give me this angle. Always give me the horizontal one. Here or on the other side here. Never give me the vertical one. Call this one theta. And we need to find this one. What do I use now for any right triangle? Pythagorean theorem first, and then a tan inverse after. So uh, C equals C equals what? 4.79 squared plus 619 squared, all under the square root. So let me do it in one shot. 4.79 squared plus 6.19 squared equals square rooted. Apparently, the overall length of the displacement is 7. What's the sigma situation? Is it always 2? Everyone? Always 2? Okay. So what's this to 2 sig figs? 7.8. So 7.8 kilometers. Okay. How about the distance? Sorry, not the distance. I mean the angle. Theta equals tan inverse. Does anyone remember what I said yesterday in the video? If you always want to give me the horizontal angle, which you should always want to give me, which of these two numbers do you always divide by the other? Always. Ahmed? Nope. Everyone, look. Okay, question. Everyone, pencils down. I'll prove it to you. SOHCAHTOA. Tan is equal to what over what? Tan is equal. Opposite over. So it's always going to be the what? The vertical one divided by the what? Always. It's the y divided by the x, 100% of the time. Okay? Always remember that. So tan inverse is equal to 4.79 slash 6.19. I know one thing about this. It's got to be less than 45 degrees. It's got to be less than 45 degrees because it did not make it exactly halfway through. So 4.79 divided by 6.19. Trig, please press shift or second because you're going backward now, and then hit tan inverse. 37.7. What is that to 2 sig figs? Which apparently happens to be a whole number, so 38 degrees. So what's your final answer? Your final answer should be written delta D vector sign or arrow equals 7.8 kilometers. I'm going to write this one here just to give myself space. Can someone tell me? So I'm going to put obviously the angle inside here. But can someone tell me what's going to go here and what's going to go here? What direction do you move first if you consider this triangle and you're trying to go from here to here, from the origin to the end of the arrow? Ahmed? Yes, exactly. See, with his fingers, he's traced it. You go east first and then you deflect up north. Done. That's it. East, north. Okay. And that's how we do what? Uh, in essence, any vector decomposition problem. How could you make this problem harder? Literally by just doing two things: adding more vectors and making all your vectors what? Bad vectors. Because then each one of them is going to what? Generate two decomposition. So it's just more work, but absolutely no new math done. Okay, next question. All right. By the way, this is literally just like one of the questions you guys see with Shivers. in probably like a couple of months when you start vectors, okay? Or maybe in a month. Vector A is in the direction 34. What does clockwise mean? With the clock or against the clock? With the clock. So apparently, so clockwise from the what though? From the negative y-axis. So what does that mean? You start at the negative y-axis, and then do you go up? So which way do you go? With or against the clock? With. So apparently, if I start here and I have to go this way, okay? All right. By the way, just so you know, I'm never gonna give you a question like this because this is not a physics question. This is a what? This is a calculus. This is a vectors question. Okay. This understanding what this means is a step for physics. But I'm not gonna waste your time giving you a question like that. Okay. I'm gonna give you a physics problem, not pure math problem. So the x component of A is ax equals how much? How much? What's the x component? Ax equals what? Negative. Interesting. That makes sense, right? Because when you turn that vector to the left, you're going to end up on the right side of the grid or the left side of the grid. Left. There you go. So now you're seeing that the signs do tell you the location of which part of the universe you're in. First of all, what is the y component of A? Second of all, what is the magnitude or the Pythagorean theorem application of A? All right, quick diagram. Let's do this. So here is my grid, a full grid. All right. Obviously, no more north-south. We can call it y and x. Okay. So apparently, my vector is tilted how many degrees? My vector is tilted how many degrees? 34 degrees. In which direction? Clockwise. Starting from which direction? The negative y-axis. So that means you pointed this way. You pointed this way. And then you turn it this way, 34 degrees. So I'm going to randomly say my vector, everyone, should be like this. Look, my vector should be this guy. All right, I'm going to erase this tip and this one. Can someone tell me where the 34 is? Is it here or is it here? Where's the 34? Exactly. It's the one that bounds my original and then my final. Okay, so it is definitely the vertical one or this guy. Okay, this is my 34. All right, so 34 is right here. 34 degrees. Can I show the breakdowns of this? Let's do that. That's the whole idea. So everyone, show the breakdown this way. Let me get closer. Show the breakdown this way. Down here, left here. Okay. How much did they say the component on the x-axis was? By the way, listen to what question I said. I did not say what is the component. I said how much is it? Everyone, when you hear the words how much or amount, what do you always give me? Negative or positive numbers? How much means size. So on a diagram, you are more than welcome just to put what? Just to put what? Not what? You don't have to put negative 16. We know you are in the location negative 16. Okay? So there's no need to put negative. Okay. What was the first question? Eric, what was part A of the question? What is the y component, which basically means what is this length right here? Whoops. I'm going to do it in red. What is, what is this guy? How can I know that? Is this a physics or a math problem? It's a math problem. It's great. It's literally grade 10 SOHCAHTOA. So everyone, let's quickly hear what. Oops, sorry. Let's quickly just extract this guy and just sketch this. Go ahead, everyone. Just sketch this. Done. That's it. We're back to grade 10. Okay, let's put some numbers. Obviously, this angle is how much exactly? That's the whole point. Yes. And how much is this one? 34 degrees. And where's the 16 in this guy? Ahmed? Exactly. If it's this guy, it's this one. So it's right here. Hello, grade 10 SOHCAHTOA. Okay, let's label. Let's label hype. Let's label opposite. Let's label adjacent. Okay, well, I guess my hype is non-negotiable. It's here. Can someone tell me where is my opposite? I always like to do opposite first. Where's the opposite to the 34? It's the 16. Yep. Which means there's no choice to label this one but adjacent. All right. Apparently, we need to find the adjacent, and then we need to find the hypotenuse. Can someone tell me how to find the adjacent? Do I use so or ka or toa? Muhammad? You use what? Okay. Which one do you know? Which one do you want to find? Which one of the triple relates opposite and adjacent only? Or which one does not care for the hypotenuse? 10, TOA, T-O-A. It's the only one that is completely what? Not caring about the hype. So for part A, everyone, for part A, use tan. Okay, so tan of 34 degrees equals opposite over adjacent, which means, okay, what's tan of 34? Well, let's find out what it is. 34, tan, not tan inverse. You already know the angle, so you don't inverse, or you don't invert. I use 4 digits, so 0.6745. So 0.6745, and I know I'm going to need an invisible one, equals. My opposite is 16. My adjacent is, well, it's my adjacent. What do I do whenever I get to something like that? Crisscross or cross multiply. So cross multiply. So you're going to get what? You're going to get adjacent times this one equals 16. Or if you want to skip a step, if you want, you get adjacent equals what? 16 divided by 0.6745. Just to save space if you like. And what do we get here? 16 divided by 0.6745. Oh, sorry. You get, now what's the sig fig situation with them? 3 sig figs. So this to 3 sig fig would be 23.7. 23.7 in meter. Done. That's it for the adjacent. As for the hypotenuse, by the way, can someone tell me how many ways there are to find the hypotenuse? How many lengths do we have at our disposal now? How many lengths do we know? We know 2 lengths. And whenever you know 2 lengths about a right triangle, how can you always find what is one way to always find the third side? Use what? Use Pythagorean. Or, but here's the thing about this one. Is this an exact or an approximate? So if you base your Pythagorean on approximate, what does that mean? Your height is also going to be a further approximate. Now we're fine with that. But what if you want to get it really as exact as possible? Yep. Exactly. Go back to the what? To the basics, to the givens, and use what? Use or relate opposite to hype this time, which is, as Ahmed, I'm pretty sure all of you know, is basically sine. So for part B, use sine or Pythagorean, but let's use sine because we have everything exact up to the sine. So that means what? We can say hype, oh sorry, sine of what? Of 34 degrees equals opposite over hype. Again, by the way, everyone look, you can even look, you can actually do it with symbols first. So hype is going to be 1 times up over sine 34. So hype is going to be, hype is equal to 1 times off, which is OPP, divided by sine of 34. In case ever you see Shivers do it in symbols first before he plugs numbers in. So 16 divided by, I don't know what sine of 34 is, 34 sine 0.55919. So that becomes 92. 5592. 0.5592, which is, you know what, I'm going to flip this number by like this. I have a flip and then times it by 16. Boom. So apparently the hypotenuse or the actual length of the vector, the bad vector, is 28.6 in meters. And I'm going to show you basically that we still ended up doing Chris. Right. Nothing changed. That's why I love teaching grade 12 physics. Really prepare you for vectors. Okay? All right. Let's go to the next third question. A fence post is 52 meters from where you stand. Okay? So everyone, look. Is it telling you which direction though? No, it's just telling you, look, everyone, eyes on me. I am here. Somewhere 52 meters from me, there's a what? There's a fence post. By the way, what does that mean? It's exactly, it's a what? So all I know is if I extend my hand and it's 52 meters and then I turn, anything I touch could be the what? Could be the location of the fence post, right? Everyone, when you listen up, everyone, when you specify only distance, you generate a what? A circle. When you specify only angle, you generate a what? Just a straight line, right? Because if okay, for example, someone could say from where Mr. Ramadan is looking, Eric is 10 degrees from Mr. Ramadan, like 10 degrees to the right. Did I tell you how far he is though? No. All I know is if I turn 10 degrees and walk, somehow or at some point I'm gonna what? I'm gonna run into Eric, but I don't know where, right? So all I generate is a what? Is an infinite line. What if I said Eric is 16 feet away from Mr. Ramadan? That means I could look, he could be 16 here, 16 here, 16, 16 all the way, right? So what am I generating? A what? A circle. Okay? So always the bit. When you generate both, then that means what? You pinpointed the exact point. Okay? In a direction 37 degrees north of east of you. Oh, perfect. So we actually know where it is. A second fence post is due south from you. So that means everyone, look, according to me, I'm looking north. Where is the first fence post? First of all, how do I turn my head? Which degree? 37. Which way? North of east. Interesting. So I have to look east first, everyone. I have to look to my east first, and then turn which way? North 37. And then I have to walk how many? 52 meters. Okay, we got that. How about the other fence post? It's only what? South of me, so it's behind me. Where? I'm not sure. It's just somewhere here. Okay. What is the distance of the second post from you if the distance between the two posts from there to behind me is how much? Interesting. That's a legit what? Cosine sine law problem, right? You can even imagine it as you say it. Okay, so let's do it. So first of all, I have to choose a spot for me. So I'm going to say I'm here. Everyone, I'm going to say I'm here. Why? Because I know that the first post is going to be on the right, to the right of me. So that's why I'm giving myself some space. All right. So we said, everyone look, imagine. This is my first north-south, and this is my east-west. Okay, apparently, where is the first fence post? Which direction? 37 north of east. So east first, and then you go up. So I'm gonna go maybe this one, up to here. All right. How much is this degree? 37. And how much is this distance? Does this look familiar? Yeah. Why do you think, everyone? Why do you think I gave you this practice worksheet? Isn't this what's gonna end up happening? Literally, you are generating these shapes or these diagrams. All right. Where is the other fence post? Where is it direction-wise? South or behind me. So that means it is right here. It is right here. Oh, sorry. Let me go back to it is right. Actually, I'm going to use black for the edges. Give me 1 second. Yep, there we go. And then black here. I don't know how long. I'm just generically going to stop here. Now, what is the distance between them? 80 meters. So I'm just going to elongate it a little bit. And this would be 80. Okay, the question basically is, how long is this guy? Okay, let's see. How many sides of the triangle do we know? We know two sides, everyone. We know the 52, we know the 80, we're missing this one. Okay? How about the angles? How many angles do we know? We only know technically one. By the way, how much is this one? How big is this angle? 90 degrees. So what's the full thing? Can I find it? Yeah, that's actually what you had to do for that practice worksheet with four triangles. So this would be what? 90 plus 37, which is how much? 127 degrees. Do you think I can apply the cosine law? Everyone, remember, when can you apply the cosine law? I told you one of the important cases. Ammar, when, when you have, okay, so, sorry, hold these. So when you have two sides, okay, and you have the angle between, do you have the angle between those two sides? No, sadly, that would be this angle. So let's try the what instead of cosine law. Let's try the what? Sine law. All right. The sine law is what? Oh, we have to label names. All right. Who cares? Let's just go with. Oh, you know what? How about we use something different than what ABC? How about we use maybe Y for U, and this is, for example, P1, and this is what? P2. Post 1, post 2, U. So that means this will be Y, this will be P2 in small though, in small in lowercase, and this would be the one we're trying to find is P1. Okay, sine law. Sine Y capital over Y equals sine P1 over P1 equals sine P2 over P2. All right, you know my style. Let's put the check marks and the question marks over what we know and what we don't. All right, what do we know? Do we know the angle Y? Yes, we do. Check. Do we know angle P1? No. So that's a red question mark. Do we know angle P2? No. Okay. Do I know length Y? Yes, we do. 80. Do I know length P1? No. I am trying to find it. Do I know length P2? Interesting. Do I have at least one fully known fraction? Yes, we do. It's the first one. Now, here's the slight problem. Which length am I trying to find? But P1 is a part of what? The fraction that has what? Two question marks. So how many steps is this problem? One or two steps? This is a two-stepper. First, you have to what? Find what? Okay, interesting. When you find P2 and you already have angle Y, can you know this one? Yes, you can. If you know two angles, you can find the what? If you know two angles in any triangle, you practically know the what? Know the third angle. Okay, so and then we have to do the sine law again. All right. So everyone, let's do the sine law first step. Sine law first step. So step number one is we're going to combine the y fraction with the p2 fraction. So sine, how much is y? 127 divided by an length of 80 must equal sine of p2, which we don't know yet, divided by p2, which is 52. Okay, so obviously we have to cross. So we will get 80 times sine p2 equaling 52 times sine of 127. So 80 sine p2 equals 52 sine of 127 degrees. Okay, so I don't know if you want to do this. You know what? At least because there's a video, so you can come back to it. Check it out, everyone. You can write P2 this way. Check, just eyes on the screen. P2 equals sine what? Look, sine what? Sine inverse. Okay, of what? Of all of this divided by just the what? The 80. There we go. This is basically the shortcut to doing like two more steps if we did cross multiplying and divided. Okay, let's do this with bed mass slowly. So first, I have to get the angle. So 127. Trig, sine it, times 52, divide by 80. I should get a decimal, otherwise there would be no sine inverse of this. Yes, we're good. And then shift, trigonometry, sine. Boom. The angle P2, the angle P2 is 31.3 degrees. 31.3 degrees. That's P2. So how can we calculate P1? Everyone, how can we calculate P1? What do I do? 180 minus the what? The 127 minus that small 31. So I'm going to do this calculation here on the side. I'm going to do it in green. P1 equals 180 full minus 127 for the obtuse minus 31.3. All right, here we are. 180, take away 127, take away 31.3. Apparently, that top angle P1 is only 21.7 degrees. And then I do the same thing. 1 second. Oh, sorry. See, by the way, this is one of the biggest tricks in grade 10 math. They always give you the two, and they see who knows that what. Oh, I practically know the third. I just need to subtract or add and then subtract. So now what do? I do sine of y. Y equals what? Sine P1 over P1. And I will leave this up to you to finish it because it's literally the exact same amount of work, just mechanical. Actually, it's less work than this one because I don't need to do what? I don't need to do what? I don't need to do sine inverse. Literally, this is just what cross multiplying and cleaning up the numbers. That's it. No sine inverting. Just finding P1. Okay. I have no idea what the answer is. I mean, I do have the solutions for the textbook. Okay. So that's how we do. Mhm. So we're done the first page. Okay, everyone, let's go to the next page. Flip the page. And I'm going to skip 1.83 because I want to do one with motion. By the way, was there any motion in the stuff we did so far? Nope. Everything was static. Everything was in its place or fixed. So that's why it was purely just displacement. So now let's do a problem with actually with an object in motion. All right. So let's go to the next page. Nope, not this one. This one. Okay. Oops, sorry. Okay, everyone. Because this will include what? Distance, velocity, speed, the stuff that we covered yesterday in the practice worksheet. So, by the way, I will post a video for just the slideshow handouts. Sorry, the slideshow for the velocity and speed. So don't worry. I just thought of doing just a worksheet yesterday. So you normally drive on the freeway. Obviously, this book was published in the States. That's why they're using Los Angeles and San Diego by two profs, actually from University of California at San Diego. So you normally drive on the freeway or the highway between San Diego, SC, and LA at an average speed of how much? What does average speed mean? I did explain it yesterday in my video. What does average speed mean? Like, okay, I don't want a scientific explanation. Just tell me what it means to you. Simplify it for me. When someone asks you, why don't you just say speed? Why are you talking about average speed? Who remembers what that means? Noura, what's your understanding? By the way, everyone here is going to say something different, which I really want to hear. Distance over time. Okay, so that's great. What's another way to think of average speed? Okay, Amar and then Ahmed. Perfect. What do you want to say? Yeah. So that okay. Think about it this way. Who's the fastest man on the planet so far? Does anyone know? Usain Bolt. Usain Bolt. His time for the 100-meter dash is 9.58 meters. Sorry, 9.58 seconds. Okay. So if you want to say, oh, so how fast was he when he was running? Someone says, oh, just divide 100 distance by time to get the speed, right? So just divide 100 by 9.58. Okay, you know what? Let's play devil's advocate. Let's do that. 100 done in 9.58 seconds. What speed did he have? How much? 10.4 meters per second. Was that his speed the whole time? That doesn't make sense. Why? At the beginning, what's any object speed at the beginning? 0. And at the end, okay, if he stops, but he didn't, okay? But we know that at the beginning for sure, he was what? He was? Okay, question. Then he accelerated, that's what we're gonna do next week, to what speed? Now here's my question. Okay, okay, everyone, here's an easy one. Let's say that your average at the end of this year, how many courses would you have taken? Let's say 8, right? Your average was 92%. Does that mean you scored 92% in every course? Is it possible though? It is technically possible, although the probability is very what? Is very low. But what does average mean? If you scored 92% average, what does that mean? Some of those courses were definitely what? Higher than 92, at least one of them, right? And some of those courses were what? Could all of those courses be higher than 92? No, then your average has to be lifted up accordingly, right? Could those courses be lower than 92? No, because then you can never score higher than what? Sorry, your average could never be what? Higher than your highest, right? Or lower than your what? It's somewhere in the what? You got it. So that means sometime his speed was what? Sometimes it was what? He was actually gunning it faster. And sometimes he was what? Of course, especially towards the what? The beginning, right? When he was just building up to that speed. Is it making sense now? That's why they call it average. Because you're not looking at the instant, you're looking at the whole interval. Okay? So apparently, uh, sometimes you were going at 105 kilometers per hour, which is 65 miles per hour. Fine. And the trip takes how long? How long? 2 hours and 20 minutes, or basically 2 hours, 0.33333, or 140 minutes, okay? 140 minutes. On a Friday afternoon, however, heavy traffic, just like here between here and Toronto, for example, slows you down, and you drive the same distance, same distance at an average speed of how much? Only 70. The question is, how much longer does that trip take? How much longer does that trip take? Okay, question to everyone. Is it still the same distance? Are you still going from San Diego to Los Angeles? So that means what? The only thing that did not change is the what? Time, speed, or distance? What's the only thing that did not change? Distance. If everyone, if you go the same distance but at a faster speed, what happens to your time if you're going faster? It shortens your time. What if you go at a slower speed? Elongates your time, right? Apparently, your speed early on was how much? 105. And it took you how long? Now your speed is how much? 70. Should it take you same time, longer, or more? You got it. So again, these logical checks. Okay, so we can just say what, everyone? We can just say, since distance. Oh, by the way, what's the equation for speed? Speed equals what? What divided by what? Speed equals this over time. Which means, can someone tell me how to rearrange this? Can someone tell me how to rearrange this equation for distance? For distance. Yes, Ahmed? Oh, Mohammed, sorry. Mohammed, go ahead, Mohammed. Exactly. Put the imaginary one here, the invisible one, and crisscross. So really, this tells you, so here's my one. This tells you that distance is equal to what? Speed times time. Oh, here's how the trick to this question. Can you calculate distance? Yes, you can. Because you know what? You know all speed and you know what? All time, right? But do you actually need to do that? See, here's the trick. This changes up. This changes what? If this changes down, this changes. What's the only thing that's always kept the same? Distance. So that means what? Distance, no matter what the two things change, is going to stay the what? You do not need to know the distance. You can just equate the what? The old multiplication to the what? To the new multiplication. Okay? Here's what I mean. Everyone, here's another way to think about it. Josh, give me two numbers that multiply up to that. Sorry, multiply to 48. Go ahead. 8, 48, 48. So if you want to say 8, 8 times 6. Okay. So everyone, 48 equals what? 8 times 6. Okay. Eric, give me two other numbers. Actually, no, don't. Give me one of the factors of 48. One of the factors or the divisors of 48. Go with 4. Okay. So that means what? You only give me 4, right? I want to know the what? The other one, correct? Am I still going to generate 48? That's the whole idea. Which means what? If those two things are the same, aren't those two expressions the same too? There you go. So 8 times 6 equals 4. For what? 4x's. And then you stop. Do you see the trick here? Did we need to know it was 48? Technically, no. I just had to make sure that you two are multiplying to the same number. That's exactly the same math structure of this one. Is it making sense now? So what I want you to write is what? Everyone, look. Distance old must equal what? Distance new. You got it. Which means what? Speed old times what? Time. You got it. Yeah. Must equal what? No. Speed new times what? Time new. Is it making sense? I am completely skipping distance now. I am using the ingredient. Speed new times time new. That's it. How many numbers do we know out of these four? We know three numbers. Of course, I can't give you a four variable equation without giving you how many? Three to know one. Okay, let's plug in the numbers. Now, let's watch out for the units, though. What units do we have? Here we have kilometers per hour. Here we have what? 2 hours and I need to convert the minutes into what? Into hours. 20 divided by 60. 3 forever. Let's take 3 decimals. Okay. So that means the old time, sorry, the old speed was 105 times 2.333. What's the new speed, everyone? What's the new speed? 70 kilometers per hour. So it's 70 times what? What's what's the symbol for time in physics? Uppercase or lowercase? Lowercase. But do you remember what I said yesterday in the video? I don't like to use t by itself. I always call it what? Delta t. I never believe when what in calculating an instant, calculate an interval. So delta t. And you can call it delta t new if you want, but it's the only thing we don't know. So who needs more subscript? So delta t equals what? Nothing. Just multiply those two, and divide by this guy. So 105 times 2.333 divided by 70. And if we do not get a time longer than 2 hours and 20 minutes, something doesn't make sense. Because we are slower, we have to take longer. So 105 times 2.333 divided by 70. Interesting. 3 point, what's the sig fig situation? Oh, that's bad because 70 is 0. Okay, obviously, if I give you a problem, it would be what? It would be with more sig figs. Let's take three sig figs. So what's 3 sig figs here? 3 point. So how many hours? Apparently, it's going to take you now what? 3 hours and 30 minutes, or 3.5 hours. That makes sense because it's longer. 3 hours, 30 minutes. Makes perfect sense. All right? Yes, Mohammed. Oh, okay, everyone. Depends on how I ask you to express your answer. If I said in hours, you are golden here. You are 100% done at this step, right? But if I ask you to express it in what? Hours and what? And minutes, you have got to give it to me in hours and minutes. By the way, sometimes, not most, sometimes I'm gonna do that because I want to see who can convert a decimal to a what? To time minute unit. Okay, and seconds sometimes. All right. Okay, that's it. We'll stop here.